Hey guys, hoping all is well with everyone. So in this video we're going to be looking at continuing this idea of the standard algorithm, and in 2.2 we kind of talked about composing tens with the standard algorithm, and 2.3 we talked about the hundreds place. Now we're going to kind of look at composing in any possible place value. So this section will definitely be talking about the thousands place as well, but I want you to become comfortable with pretty much this idea of carrying and representing those next highest place values, and avoiding, as always, those multiple digit numbers in one single place value, because we can't do that. So up to this point, there's been a lot of core math. Mostly what I mean by that is, like, we've been plugging and chugging and kind of really just doing the really kind of grunt work of, adding the numbers. And to this point, we haven't really seen anything as a visual aid of kind of representing this idea of the algorithm, or even this idea of carrying. And I think that 2.4 is going to do an excellent job of that based on the visual aid that we're going to be looking at. So for the step in question, it says, what does the table show? So remember that tables are usually set up in columns and rows. So the columns themselves represent which week we're looking at for drink sales, and then the rows represent the type of drink, whether it be juice or milk. So it's in a 2x2 table with the first and second weeks, and then the two types of drinks that we're looking at in question. So it says, how could you calculate the total drinks sold in week 1? Carter the reindeer, I'm guessing, or a deer, I guess he's a deer. Carter used blocks to represent the sales from each type of drink. He then moved the blocks together to calculate the total. So what's great about the whole block figure is it shows you the representation of each place of value with pictures of that number of blocks. So what I mean by that is, for week 1, the juice is 614. So in the ones place we have 4, and we have 4 individual little blocks. So that allows us to represent that single place value. In the tens place, we have a group of 10, which is 10 ones, which in previous sections we've mentioned that because we can't put a multiple digit number in a single place value, we can represent it as 1 or 10 groups of ones in this case. And that's what that one string of blocks does. It represents 10 ones, but since it's in the tens place, we can represent it as 1 being 10. Okay? So those two numbers together, if we have 4 individual blocks, and then we have one group of 10, or string of 10 blocks, that's 14. So that's kind of where we get the 14 from in those first two place values in question. Then we look at the 6. Well, if we look carefully, we don't have to count all of these blocks to see how many there are. What it is it's a 10 by 10 block grid. So each of these 10 by 10 block grids represent 100. So what's fantastic about that is that it shows us that each place value is represented by a different model picture. So the hundreds place is represented by the 10 by 10 grids, the tens place is represented by a string of 10, and then the ones place is just represented by individual 1 cubes. So it's really helpful to break things up into a representation of each place value. So again, in the ones place we have 4, in the tens place we have 10, but we represent that 10 as 1 in the tens place, which is where that 1 in 614 comes from. And then we have 6 groups of 100, or 6 groups of 10 by 10 grids, which is 600. So that's how we get 614. Now, let's go ahead and look at the milk. Again, we have 1 cube that's by itself, representing the ones place, so that's where the 1 in 531 comes from. But in this case, we have 3 blocks, or 3 strings of 10 blocks. So that represents 30. And the reason that it's in a string is because if we kind of did the same thing as we did in the ones place and just let them be kind of individual blocks, we would kind of see them as the same representation model of the ones place, and we don't want to do that. We want to represent the tens place in a different kind of way to show how the ones place is different from the tens place. So that's why this string of 10 is helpful. But since there's 3 strings of 10, that accounts for 30. So since it accounts for 30, we have 3 representing 30 in the tens place. Okay, because 3 groups of those 10 blocks is 30. Okay, and then the same thing with the hundreds place. Those 10 by 10 grids each represent a group of 100, but since there's 5 of them, there's 500. Okay, so essentially what you can do for each of these, and I'll kind of go ahead, is in my last video I mentioned that if you were to add the individual place values together and add those numbers up, you would get the same value as if you use a standard algorithm. So let me go ahead and show you what I mean by that. So in terms of how many ones there are 4. You just want to make sure that all of your place values are also lined up. This is going to be for week 1 juice, so 614. In the tens place, or we have one group of 10. So I'm going to model that with 10. Okay. And then we have 6 groups of 100, so that's 600. Oops, that's kind of, sorry about that. So if I added this up, and again, each of these numbers, 4 ones, 110, and 600, this would add together to be 614. Okay. So let me go ahead and kind of show you the other, the milk. That's going to be 531. So I have 1, 1. I have 1 in the ones place. I have 3 groups of 10, which is 30. So that's 3 in the tens group. And then I have 5 in the hundreds group, or 5 10 by 10 grids. So this added together is 531. So if we represent the addition of each of the place values and their representative model, being that the ones place is the individual cubes, the tens place is the stack of 10, line of 10 blocks, and then the hundreds place is represented by those 10 by 10 grids, we get the same result as if we were to use a standard algorithm in the addition. So what I want us to kind of see here is that up to this point, again, we haven't seen a visual model, and this visual model is fantastic to show how we represent each place value. Okay, so let's go ahead and continue. So what number do the blocks show? How do you know? So the truth of the fact is that each of these individual blocks represents 1. And the reason that we know that is because if we have one single little cube by itself representative in the ones place, we have 1. But each of these little, cubes represents 1, and then when we have 10 of them in a straight line, we have 10 ones, but we can represent that as a group of 10. If we have it in a 10 by 10 grid, instead of saying 100 little individual cubes, we can just call that one group of 100, which allows us a lot more comfortability with the place value concept. Okay. What is another way to represent the same number? So we kind of, as he did, he would regroup 10 hundreds blocks as 1,000s blocks. So this is going to be really important when we start to go into a higher place value than the hundreds, which we have been kind of going over with this section as a review and the past section. So another way to represent the same number is to use these blocks and represent their values in a place value kind of column situation. So that's kind of what I did here, because we can represent the ones place as 1 for 531. We have 10 groups of 3 groups of 10, so that's 30, and then we have 500, 5 groups of 100. So the question now is, how could you calculate the total drinks sold in week 2? This is going to be using the standard algorithm, but now what we're going to see is that you can group 10 groups of 100, and that will give you 1,000. So that's really important, but we want to really keep in mind our two main rules here that kind of go hand in hand with each other. The first one is that we cannot represent a multi-digit number, or a number that is 2 digits or higher, in a single place value. We're not allowed to do that. Another thing that we have to keep in mind is if we are forced to only represent one value in a single place value, we have to carry the next place value into the next highest one. So let's kind of go ahead and look at that. So this is Karen. I don't know who Karen is, because I'm pretty sure Carter is the deer, but that's kind of beside the point. Karen used the standard addition algorithm to calculate the total. What number should she write to complete the calculation? So let's review here. Again, remember your place values, and this is going to be important because we're going to be looking at a new place value here. So we have 1, 10s, hundreds, and we'll get to the next one in just a couple moments, but let's go ahead and use our algorithm here. So 7 plus 5 is 12. We have to represent the ones place in the ones place, ones place of 12 in the ones place. So that 2 is the ones place of 12. But we carry the 1, and that 1 almost represents like that string of 10 blocks. It represents 10, but in its own place. So we can represent it as one group of 10. So now we can take 1 plus 5 plus 3, but remember, these are groups of 10. So this is essentially like 10 plus 5 plus, or 10 plus 50 plus 30. That's 90. So that 9 in the tens place represents 90. And we can think of that, that holds true, because 57 plus 35, without even going to the next part of the algorithm or the next place value, 57 plus 35 is 92. So we can kind of see that that would be 9 groups of 10 plus 2 little ones, or 2 individual cubes. Okay? So now comes the next part. So 8 plus 4 is 12. Again, we have to follow our same kind of rules here. So we're going to represent the 2. So these are groups of 100. So this is 800 plus 400. 800 plus 400 is 1,200. But since this is the hundreds place, we have to go to the hundreds place of 1,200 and represent that number alone. Then we have to carry the 1. That 1 is now going to be in the thousands place. So, because now we're representing a group of 1,000. Ones would be a cube, tens would be a block or string of 10. The 100s would be a 10 by 10 grid. Thousands place, we could be, I don't know, we could pick a blob if we wanted to. But it would be basically, as Carter said here, 10 blocks or 10 groups of those 10 by 10 grids to give us 1,000. And then when we bring that down, that's going to give us 1,292. Now remember, going back a little bit, when we are looking at where to put the comma We always want to separate the thousands from the hundreds, tens, and one place. So that comma represents that one group of 1,000 and separates it from the 292. Remember, in a comma in math almost works the same way as it does in English. Its job and role is to give us a brief pause, and that allows us to separate the thousands place from the hundreds, tens, and ones. So we say 1,000, brief pause, 292. Okay? So Karen adds 8 and 4, she gets 12, but she can't represent 12 alone in the hundreds place. So essentially what is going to happen is we'll put the 2, and then we'll carry the 1 and bring the 1 down, that 1 being in the thousands place. So what does the 12 actually represent? It represents 800 plus 400, which is 1,200, or 12 groups of 100, or 1,200. Okay? Alright, let's look at the next page here. Alright, now we're going to get into some bigger numbers here, but again, the strategy is just the same, so no, you don't want to be intimidated by any of this stuff. We can definitely handle this. So, the step-up question says to estimate the total sales for each week in your head, then use the standard addition algorithm to calculate the exact total. Okay, so these again, this is a 5x2 table here. So the columns represent the weeks, and the 2 rows represent the type of food, being the veggie burger and the grilled chicken sandwich, which actually sounds really good right now. So let's go ahead and estimate, and what we're going to do is we'll estimate to, if it's 1,000 or greater, we'll represent to the nearest 100. If it's less than 100, we'll round it to the nearest tenth. Okay, so we want we want to be somewhat specific here. We don't want to round too generally. So let's go ahead and look at these. So for, let me see if I can use orange here. Okay, so for week 1, the veggie burger will round to 1,200. For the grilled chicken sandwich will round to 1,300. For week 2, we'll round 748 to 750. And again, if you guys have any questions about reviewing of rounding, please don't hesitate to let me know. 1,055 will round to 1,100. Week 3 will round 915 to 920. So again, if it's under 1,000, I'll round to the nearest tenth. 1,230, I'll round to 1,200. 1,324, I'll round to 1,300. 1,197, I'll round to 1,200. 1,201, I'll round to 1,200 as well. And then 997, I'll round to 1,000. Okay. So there's our there's our estimate for each of the foods in each of the 5 weeks. So if we were to take the week 1 totals, we should get around 1,500 as an estimate. So estimate, we should get 1,200 plus 1,300 is 2,500. So let's go ahead and take the sum. So again, despite how many place values we have, our strategy is the same. So 7 plus 5 is 12. We can't represent a 2-digit number in the one single place value, so we put the ones place of 12, which is 2, in the ones place, and we carry that 1. So think about that 1 like that string of 10 that we saw in those block visuals. So now we have one group of 10 plus another group of 10 represented in the tens place. So this represents 2 groups of 10, which is 20. And we can think of that too as 17 plus 5 is indeed 22. So far so good. Then we have 3 plus 5, which is 5, but that's, again, representing hundreds. And then 1 plus 1 is 2. So our final answer is 2,000, 522. Okay, so not too bad. Let's look at the next one. So the next one, the estimate should be 750 plus 1,100. So our estimate should be about 1,850. Okay. Alright. So 8 plus 5 is 13. We put the 3, carry the 1. So that 1 represents a group of 10, like that line of 10 blocks. This represents the tens place, so we have 1 group of 10 plus 5 groups of 10 plus 4 groups of 10. That's 10 groups of 10. So we have to represent the tens place of 100, so that's going to be 0, and then we carry the 1 because that's 100. Now this 100 is represented in the hundreds place as just 1. So now we have, in the hundreds place, 1 group of 100 plus 7 groups of 100, and that's 8 groups of 100. And then we'll bring down the 1. So, and again, we can think about this as 55 plus 48 is 103. So we have the 03 here, and then we have the 100 part of that in representing itself in the hundreds place. And then we'll add that 7 groups of 100 to it as well. Okay, so this one's a little bit more generalized. It's a little farther from our estimate, but that's okay. And the reason for that is, again, the way that we estimated. So I estimated 1,055 all the way up to 1,100. So that's kind of why we're off by almost 50. Okay, let's look at this next one. So our estimate for week 3 is going to be 920 plus 1,200, so that should be 2,120 should be our estimate. Okay, so 0 plus 5 is 5, oh sorry, so this should be 2,120. So 0 plus 5 is 5, we don't have to carry. 3 plus 4, or 3 plus 1 is 4, sorry about that. Again, we don't have to carry. So far we have 5 ones, which is like 5 little individual cubes, and then 3 plus 30 plus 10, because again this is the tens place, so we have like 4 of those string of 10 blocks. Okay, and again 30 plus 15 is indeed 45, so far we're good. 2 plus 9 in the hundreds place means 200 plus 900. That's going to be 1,100. So we put the 1, which is the hundreds place of 1,100, but then we carry the 1, because we are now going to represent the 1,000, the thousands place of 1 in the thousands place. So this would be like our blob, so to speak, that we thought of to represent a visual of the thousands place. So these are now thousands, so 1,000 plus another 1,000 is 2,000. Okay, and then a comma. Gotta be really careful about your commas, because you want to make sure, again, that you're separating the thousands from the hundreds, tens, and ones place. Alright, let's look at week 4. So our estimate for week 4 is going to be 1,300 or 1,300 plus 1,200, that's 2,500. So we have here 1,324. Make that a little bit more spread out. And we're going to add 1,197 to that. So we'll go ahead and add this. I'm going to go ahead and kind of use the column plan that they use here. So we have 4 plus 7, which is 11. Put the 1, carry the 1. 1 plus 2 plus 9 is 12. But remember, this is 10 groups of, or I'm sorry, this is 12 groups of 10. So that's going to be 120. So we put the 2 here, representing the tens place of 120, and we carry this 1, being that that is one group of 100, now represented in the hundreds place. So we have one group of 100 plus 3 groups of 100 plus another group of 100, giving us 5 groups of 100. And then we take the thousands place, add 1,000, and another group of 1,000, and that gives us 2,521, which was very close to our estimate. So 2,521. Okay. Alright, let's look at week 5. So week 5 is 1,200 plus 1,000, so our estimate should be close to 2,200. Alrighty. So let's go ahead and we have 1,201 plus 997. And what's great about these columns is, again, they help you keep organized with your place values. So, and if you want to, you can always put your place values here. So you have ones, tens, hundreds, and for thousands, you can either put, you can put TH. But again, the only reason that you want to be careful with the letters is you don't want to repeat the same letter you used for a previous place value. So we use T for tens, so we don't want to use it for thousands too. So we'll go ahead and take the sum here. So 1 plus 7 is 8. I don't have to carry. Oops. 0 plus 9 is 9. I don't have to carry. 2 plus 9 in the hundreds place is 200 plus 900, which is 1,100 or 1,100. So I'm going to represent the hundreds place being 100, because this is representing 1,100. So there's 100 there, but I have to carry the 1 from that 1,100, because now I'm going to represent that 10 groups of 10, or I'm sorry, that 10 groups of 100 as 1,000 in the thousands place. So I do 1 plus 1 in the thousands place is going to be 2,000. So my result is 2,198. Okay. Alrighty. So 2,198. Alright. So it says use the totals above to help calculate these totals. So what they want us to do is use the totals that we just came up with to add together weeks 1 and 2, and then 3 and 5. So our week 1 total is 2,522. So these are going to get some pretty big numbers here, but again, keep in mind the strategy doesn't change, okay? So we have 2,522 plus 1,803. So these are step-up questions, which usually can be a little bit more involved, but the strategy will be just the same, so we got this. So, alright, so remember, take it one place value at a time. 2 plus 3 is 5. I don't have to carry. In the tens place, 2 plus 0 is 2. So that represents 20, or 2 groups of 10. In the hundreds place, we have 5 plus 8, which is 500 plus 800. That's 1,300. So, or 1,300. So I'm going to represent the hundreds place of 1,300 here, and I'm going to carry that 1, and that 1 represents that thousands group, okay? So now I have this 1 plus 2 plus 1 in the thousands place, so I have one group of 1,000 plus two groups of 1,000 plus another group of 1,000, giving me 4,000. So, and then our final result will be 4,325. Okay, and then we have weeks 3 and 5. So we have 2,145. Plus 2,198. Okay, this is going to be a little busy, but we got this. Alright, so let's go ahead and take it one place value at a time. So we have 5 plus 8 is 13. I'm going to put that here because it's going to be in our answer. We have to carry the 1 because, again, 5 plus 8 is 13, but we can't represent 13 in the 1's place. So we're going to drop the 3 from the 1's place of 13 and carry the 10's place, being 1 of 13, because now it represents itself as one group of 10 in the 10's place. 1 plus 4 plus 9 in the 10's place is the same as saying 10 plus 40 plus 90. That's going to be 140. So we have to represent the 10's place of 140, being 4. And then we have to carry that 1, because that's representing the hundreds place, or that one group of 100. Now remember, that group of 100 is 10 groups of 10. So now this hundreds place is going to be one group of 100 plus another group of 100 plus another group of 100. So 1 plus 1 plus 1 is 3. And then last but not least, in the thousands place, we have two groups of 1,000 plus another two groups of 1,000, giving us 4,000. So our answer is 4,343. Okay? Alright guys, so that does end section 2.4. Again, if you have any questions or concerns or anything that I can answer or help you out with, please don't hesitate to reach out. I hope this helps, and again, thank you guys always for watching, and please take good care of yourselves, and hope to see you soon in our continuation with lesson 2.5. Take good care. Bye.